Good morning, students. Good morning. Very good morning. Very good morning. Am I audible? Voice? Yeah, very good morning. Very good morning. Okay. So yesterday only we met for the class of the Lewis dot structure, or we have done the bond parameters. I hope that by this time you have revised the notes. Yeah, very good morning to all. Yes. Papuram, Sajid, Manish, Shweta, Shanya, Kirtana. All very good morning to all. Yesterday we have done the bond parameters, right? Then we have discussed about Lewis dot structures. We have discussed about the formal charge concept. So by this time, have you gone through the notes or NCRT? Good morning, Shweta. Good morning, Ramarao. Good morning. Good morning. Tell how many of you have gone through this part? How many of you have gone through the initial portion, which is Lewis dot structures, or other one is formal charge concept? This up to this part you have gone through. Yes, up to this page. 105, 102 to 105. Okay, Sajid, very good. Manish, yes. Papuram, good, very good. These three students, remaining students, have you gone through the yesterday's class part, which is bond parameters, that is mainly from the notes. Then Lewis dot structures and formal charge. It is from NCRT. Very good, Shanya. Very good, Chintu. Bhavya. Very good, Kirtana. Very good. Good morning. Good morning. Naveed, Vijay. Good. Very good. Your main target is whatever topic you are doing in any subject, try to cover at least that notes part same day. Solving of the questions or reading of the any other material is your second priority. First priority is same day you have listened to the lecture, try to learn that, revise it multiple times same day. Then if time shortage is there, you can cover it within 2 to 3 days by solving it. But learning the notes, understanding the class notes again, it is very important. Then in your memory it will be retained for longer period of time. So make this habit. Class is there, same day you will learn that concept from the notes, whichever subject it is. Do not think today I'll do chemistry, then physics, and like this. Always divide the time. Time management is most important thing. Okay? So I'm giving you some idea that you will not leave the chapter or notes same day. You have to learn it whenever it is completed. And if possible, if your time management is good, you can try to solve some questions from the module. 40% solve, 30% solve, 100% solve, best it is. Yes, Kaushik, good morning. ठीक है, चलो बताओ. अब now firstly, what are your doubts? What are your doubts in that? Because writing the structures are very important. Yes, Akash, very morning. Good morning. Writing the structures are very important. Practicing is must. The moment you practice it, you work on the subject, surely you are going to improve. You will be the same better version within few months. That is required. With time, we have to improve in terms of knowledge. For you also, it is important. For me also, for everyone. So any doubts you have firstly up to the last class, any example we have done, because test is also there, na? It is on Monday by this time, because Sunday classes are there. Any questions from your side? Otherwise, I'll start next part, which is the formal charge example we have done. Any questions from that? You have tried the question, any questions from that you want to ask? From the formal charge. Any questions from the formal charge or Lewis dot structure or else shall I start with the, but you have to read all this portion which is given here in the bold. Okay, you have to read this portion in the bold, then back page also some example given, NO2 minus CO already we have discussed. Okay, shall I start resonance concept? Shall I start this one? It is very precisely given in chemical bonding. Detailed part is in the organic portion. ठीक है स्टूडेंट, स्टार्ट करें. ठीक है, चलो. That means you have no doubts. It means either you are getting all or you are having not practiced well. What is the case? You have solved mostly questions or yet to be solved. That's why you are not able. You are not asking any questions on hybridization examples. I have given 31 examples, and then any questions not asking. No problem. It's good that you are solving it completely. That is required. Now here, in this part, bond order given. Bond order means, yesterday I have discussed that bond order means what? Bond order basically means number of bonds between the two atoms. General meaning is that. Here some information is given. Example given of isoelectronic ions and molecules which are isoelectronic, their bond order will be same. At this point we will use in the molecular orbital theory. Like N2 example in MOT we will do. So by that time you will understand. Then resonance structures. Now firstly, what is the meaning of resonance? Resonance is basically delocalization of pi electrons. Okay? Delocalization of pi electrons. And what is required? A conjugated system is required. What is required for that? A conjugated system. What is conjugated system? Pi sigma pi arrangement. Pi sigma pi, in which parallel orbitals are there. Mostly p orbitals, but d orbitals also possible, because we are talking about inorganic chemistry examples. In organic portion, the carbon is there. So what is the case? Parallel p orbitals has to be there. But when we talk about broader term, it is the parallel orbitals network. P orbitals also possible and d orbital also possible. So simple term is resonance is delocalization of the pi electrons in a conjugated system. Okay? Or simply it is a delocalization of the pi electrons. Getting it? Then here, example given which is of ozone. So it is a pi sigma pi arrangement, or it is a which arrangement? Lone pair sigma pi arrangement, or pi sigma lone pair arrangement. These are the terms which are useful for which one? Resonance delocalization, because it is termed as the conjugate system. Pi sigma lone pair, pi sigma negative charge. These are the terms which in detail we do as we write the different resonating structures. Clear? So what is the use of resonance? See, in case of ozone molecule, if you go by the structure, one structure, you will find that one bond is single, other bond is double. Bond length also given different. If you go by the second structure, you will feel that here it is double bond, there it is a single bond. But practical observation is, or experimentally what is observed, the bond length is in between 148 and 121. Practical observation. Theoretically, two bond lengths are there, right? But experimentally what is observed, both bond lengths are identical and they are lying between single bond and double bond. They lie between single bond and double bond, so you can say it's a partial double bond character. So how can we explain that experimental fact that bond length is not single, bond length is not double, it is in between them? Then we have to use the concept of resonance, that pi electrons are continuously delocalizing, like here also single bond, here double bond, second structure here double bond, and there single bond. So the actual structure will be a hybrid of these two. Actual structure will be hybrid of these two, which is written as third here. It is written as Third, it is resonance hybrid. The actual structure is named as what? Resonance hybrid. It will look like this only. It will look like this: partial hair bond, partial hair bond. Getting it? So these are two different structures, because by one structure or by one Lewis structure we cannot explain the properties of the molecule. Hence we write different Lewis structures. These different Lewis structures are known as resonating structures or canonical structures or contributing structures. These are the multiple names. Okay, by one structure we are unable to explain the properties of a molecule, so we write different Lewis structures. These different Lewis structures are known as which one? Resonating structures. And actual structure is which one? Hybrid. Okay? So therefore, by this way we have explained why a ozone molecule has same bond length. Here is explanation is given. So when you read it, you understand the idea which I have explained. You will still read the NCERT line. Here it is given in the bold. When single structure cannot explain, then in resonating structures we will never change the position of atoms. What will not change? Position of atoms will not change. What will change only? Position of pi electrons, or we can say position of pi bonds. Clear? What will be same? Position of atoms remains same. That means it will be sigma bond network remains same. What is changing? Location or position of pi bonds. We keep on delocalizing the pi electrons and it will give you different position of pi bonds. Then here two examples very important. One is carbonate ion. In carbonate ion, if you observe, we have done this structure in the hybridization as well as VACPR, and in Lewis dot structure also it is given. So in carbonate here double bond and single bond. Okay? That means theoretically there are two types of bond lengths. One double bond, C double bond O, other will be C single bond O. But what is experimentally observed? Both CO bonds are of same bond length. Here it is, when you read the explanation, experimental finding, all carbon oxygen bonds of in CO3 2- are exactly equal. So how can we explain that why this is equal? We will explain by resonance delocalization. These are the structures possible, and hybrid will be which one? Partial double bond character between every C double bond. Getting the idea? I'm just explaining the NCERT part right now so that when you read NCERT you can do it very fast. Then explain the structure of CO2 molecule. In CO2 molecule, what is the observation here? Observation is the carbon oxygen bond length in CO2 is 115, which is between which one? Double bond O and triple bond O. That is important point. That in CO2 also the bond length of CO is not exactly equal to C double bond O, not exactly equal to C triple bond O. Experimentally it is proved. Then we can explain it by which concept? Resonance. How? These are the three resonating structures given for CO2. These are the resonating structures. I will write also when we'll do the example in resonance. So these are two important, and CO2 is very important because if you do not go through this example, you might get it incorrect. Then these are some theoretical points given. Like resonance means delocalization of electrons. By delocalization, system gets stabilized because energy is released. So here resonance stabilizes the molecule as the energy of the resonance hybrid is always less than energy of any resonating structure. Means resonance hybrid or actual structure is always more stable than any of the theoretical resonating structures which we have drawn by delocalization of electrons. Clear? Other point, resonance averages the bond characteristics of a molecule. Means we are writing the different arrangement of the bonds. So it is overall useful for statement type of questions. Then misconceptions are there. So you will still read the misconceptions. Like, Canonical forms have no real existence, means we are writing all the resonating structures theoretically. They have no real existence, or we can say resonating structures are purely hypothetical in nature. We cannot separate these structures by any method. Then what is the other misconception? Molecule does not exist. Many misconceptions. You should remember that. So we have to remember this point. Molecule does not exist for a certain fraction of time in one canonical form. Means the carbonate final structure hybrid will not be staying for some portion of time like this, then shifting to this, then shifting to this. This is not going to happen. These are only hypothetical structures. That is the meaning. Molecule does not exist in any of the forms for fraction of time, like 15 seconds, this one, 20 seconds. No, because these are all hypothetical structures. Then there is no equilibrium between resonating structures, which is related to keto-enol form. That there is no equilibrium between one resonating structure with the other. Why there is no equilibrium? Because these are hypothetical structures, no real existence. On paper we are writing it. The molecule as such has a single structure, which is always molecule has which structure? Actual structure, which is resonance hybrid. But to understand the molecule, what we do? We write different structures with proper bond. Otherwise, in real, what happens? Electron density will keep on delocalizing. So these points, why important? If any statement type question given, that time you will not miss it. That is why I keep on saying, read the NCERT line by line. ठीक है? Now going through the resonance concept. Write down in the notes resonance. It is the delocalization of. It is the delocalization of. It is the delocalization of pi electrons. It is the delocalization of pi electrons in a conjugated system. In a conjugated system. In a conjugated system. Then you can mention types of conjugated system, or you can write few types of conjugated system, because we are not discussing all types here. Why? Because here in this topic in NCERT very less information is required. Detail will be done in the organic portion later on. One way is pi sigma pi arrangement. Double, single, double, or triple, single, double also possible. General term you understand, then by writing the structure you will be able to write the structure also with different possibilities. Pi sigma pi arrangement, or other possibility pi sigma lone pair. Pi sigma and any atom with lone pair. Group, I have written group. G is any group, oxygen, nitrogen, whatever. So that is the meaning here, that it is pi sigma lone pair. Pi sigma and lone pair. Other possibility, pi sigma negative charge on any atom. In bracket I can write pi sigma negative charge. Pi sigma negative charge. These three may be easily useful here as per the chemical bonding topic. Pi sigma pi arrangement, you will say resonance. Pi sigma negative charge, resonance. Pi sigma lone pair, resonance. Okay? Then you can mention etc. because all other possibilities of radical carbocation I am not writing for this part here in the chemical bonding. Now, example which is given here, ozone. In case of ozone, firstly we know coordinate bond, you can mention, otherwise you can write it like this also. It is pi sigma lone pair. Lone pair always move away from the atom. So here pi electron delocalize, here double bond, and these electrons will shift on this one. So by arrow, if you write it, practice always by arrow, because at initial stage it is helpful. Pi delocalization takes place, then you will write, here it will be, suppose minus I am writing, here it is plus I am writing, so there it is shifted, it becomes double bond, lone pair as it is, here plus, and there it will be minus. And this becomes 3 now. Getting it? This is the delocalization of pi electrons. Then its hybrid form is, both side you will write oxygen here, oxygen here. Here you can mention delta plus, here you can mention delta minus, or you can overall write without any charges, then also correct. In NCERT they are not using this type of structure. Getting it? Here double bond, in other structure here single bond. So final actual structure, these are which structures, bhai? These are resonating structures, or other name is canonical structures. Other is canonical structure. And this will be what? This will be actual structure, which is resonance hybrid. Written? Getting in this point? Yeah, these are equivalent structure, but you can say these are resonating structures. Equivalent depend upon the which example. Like here it is equivalent structure. Why? Here also O minus, that is double bond O. Here it is O minus, here it is double bond O. Negative charge is uniformly distributed on oxygen only. Other example, all of you easily can relate in case of benzene. Pi sigma pi sigma pi. So what we will write? We can delocalize the electrons. Completely conjugated system. And here it is double bond, here shifted here, and it is. So final hybrid structure will be this is the hybrid form. Written? आ रहा है समझ में? चलो. So write down now the point which is given in the bold there. Mention here. To explain the properties of a molecule, different Lewis structures are drawn. Different Lewis structures are drawn, known as resonating structures, RS, known as resonating structures or canonical structures, known as resonating structures or canonical structures or contributing structures or contributing structures. Then write down next point. Resonating structures are hypothetical. Resonating structures are hypothetical. Resonating structures are hypothetical, but they contribute towards actual structure. But they contribute towards actual structure, which is known as resonance hybrid. Which is known as resonance hybrid. Which is known as resonance hybrid. Next point. Resonance hybrid, RH, short form you can write, these are your notes only. RH means resonance hybrid. Resonance hybrid is more stable. Resonance hybrid is more stable than any of the resonating structure. Resonance hybrid is more stable than any of the resonating structure. Next point. Resonating structures cannot be separated by any method. Resonating structures cannot be separated by any method. Resonating structures cannot be separated by any method. Okay. Can you explain why they cannot be separated by any method? Why they cannot be separated by any method? Why resonating structures cannot be separated by any method? Reason is very good. One response is there. Very good. Sharanya is there. Durga Prasad, because they are most stable. Nahi Vijay, nahi Durga Prasad. Sharanya, because they are stable. Nahi Sharanya, firstly you have given the right answer. Hari is right. Bapuram, Janvi, nahi. Dinesh, right. अरे भाई ब्रेकफास्ट नहीं किया तुम लोगों को लग रहा है. Yes, Sajid, correct. CH, Lachana, correct. Yes, answer is they are hypothetical, काल्पनिक. They have no real existence. भाई जब existence ही नहीं है real, how can we separate them? These are only written for understanding about the properties. We are writing different possible structures. These different theoretical structures are what? Resonance structures, resonating structures, and these are all on paper they are hypothetical. ठीक है, next point mention. Next point में you can mention that the energy difference between most stable resonating structure, the energy difference between most stable resonating structure and resonance hybrid and resonance hybrid is known as resonance energy. Is known as resonance energy. ठीक है? So this term here not given, but in this is part given in the organic chemistry where resonance is again given. So that time this term will be used. Resonance energy means what? The energy gap or difference between which one? Hybrid structure and most stable resonating structure. Most stable resonating structure is still less stable than which one? Resonance hybrid. How much less stable? That energy difference is known as resonance energy. Higher is the resonance energy, more is the stability of that molecule. ठीक है, तो as per the chemical bonding, these are the theoretical points. ठीक है, apart from this you will read the NCERT resonance misconceptions, you will add or you can underline there itself. ठीक है, start करें writing the structures. So in writing the resonating structures, which point you will take care that there must be a conjugate system. Okay, and you will never change the position of atoms. Only what will change? Only the position of pi bond will change. ठीक है, this point you will consider. Other point you will consider that negative charge should be on more electronegative atom and positive charge on less electronegative atom. ठीक है ना, तो we will focus purely on few examples here as per inorganic part. Not writing carbon chain structure, benzene structures detail. Okay, so first example, so already you have written ozone. Other example you can write here another ion which is carboxylate ion. Negative single double bond, pi sigma negative. It is also a type of conjugated system. So you will do what? Negative charge always move away from the atom where it is present. CH3, C single bond, O minus double bond. These are the two equivalent resonating structures of carboxylate ion. You can write hybrid if required. Resonance is between them. So hybrid we can show in this manner. Hybrid will be like this. Here partial bond, here also partial bond. Here -1/2, here also -1/2. Or you can write overall charge -1. Both are correct ways. Getting it? Other structure which is given in NCERT as example is carbonate ion. In carbonate ion, there are delocalization possible. Which one? Negative sigma pi. Here also negative sigma pi. We can delocalize from any of them one by one. Suppose from right side, this will shift here, this will go here. This becomes O minus, this becomes double bond O, it is minus. Other possibility, left one, C double bond O, O minus, O minus. What I am doing, I am simply delocalizing. That means moving the pi electron density whenever a conjugated system is there. That three I have written. Pi sigma pi, do the delocalization. Pi sigma negative charge, do the delocalization. Pi sigma lone pair, do the delocalization. Up to this point clear? अरे भाई आ रहा है, समझ में नहीं आ रहा? Or you are waiting for breakfast only? No, hybrid is only one structure, not two. These are resonating. Acha, Sign of resonating structure is this one. Double-headed arrow means resonating structure. Double-headed arrow means resonating structure. If I write triple bond like this, like in ozone I have written, that is meaning of hybrid structure. Okay? Now other example important. What is given there? Second example, very, very important. What is that? This is charge. If you want, you can show. -1 charge on how many atoms? 3 atoms. Yes. So you will write how much charge will be there? -1/3. If it is given in the option, you can mark that one. Other structure you can write for CO2. ठीक है? नहीं, hybrid is there ना. Hybrid is always there, भाई. Actual structure is hybrid, but we do not write hybrid for every case. Why? It is not given also every time. It is only for understanding this. Yes, these are double-headed arrows, resonating structures. Actual structure will be average type of this one. Clear? Ramanath, clear now? Hybrid structure means actual structure, भाई. We do not write every time for every resonating structure. Clear? Because it is not required every time. When it is given, then we can go. For some structures, we write for understanding. Here CO2, I can delocalize from right side, lone pair away, and this will go on the oxygen. It will become oxygen triple bond, carbon single bond, oxygen here plus, there minus. Second possibility, if you delocalize on the from the right to the left side, exactly opposite. Here triple bond O, here single bond O, this minus, this is plus, lone pairs are there. Lone pairs are there. Wherever it is required, we can mention. If it is not mentioning, understood it is, these are present. Negative charge oxygen means how many lone pairs? 3. Positive oxygen with 3 bond means 1 lone pair is present. Getting it? 3 resonating structures given. Clearly this example is given there. And bond length is not equal to double, not equal to triple. Where? Where Kaushik? There, 2 there. You, YouTuber 2 लिखा हुआ. I thought he is writing 2 as a structure. There, sigma bond not there. How? Why sigma bond always there na? Sigma bond to always there. It is only delocalization in pi electrons. अरे भाई कोई doubt? अच्छा, conjugate system. Yes, it is also a type of conjugate system. How? You can take this is as a lone pair. Here you can take sigma electrons present and other one pi. Why I am taking? Because when you write the structure, it is not violating any octet of the second period element. So by practice, we understand that some basic outline is there, pi, sigma, pi, but it is possible in other cases also, like CO2. If you delocalize the lone pairs here, it is undergoing without any violation of the any octet rule. Yes, write down the structure. Kaushik, clear? So firstly, we understand basic rule of delocalization. Then with different set of examples, this might vary. But once we are understanding how to delocalize and the final structure means other resonating structure, if it is not violating any octet rule, write it, no problem. Write down for NO2 minus. Write down for NO2 minus. NO3 minus. Try these structures. Return. Very good. NO2 minus. NO2 minus में firstly when you write the structure, we have done where in hybridization. NO2 structure, NO2 minus. This is the structure of NO2 minus. But here I am not writing lone pairs like this. Our target is to write the resonating structure, delocalize. Getting it? Yes. Other one, NO3 minus. Delocalization will be there on every oxygen. Suppose I am writing this is the structure. You can write coordinate bond also. Correct it is. No issues with any of them. I can write coordinate bond. All are correct. Other way is this becomes minus, it becomes double bond O. Other way is this becomes here double bond. ठीक है. Another possibility, this becomes double bond O and this becomes NO3 minus. In short, we will write double bond everywhere. Here also, there also, there also. I can remove this dirty bond, I can write plus minus, so minus minus shared, minus minus like this, minus minus. Okay? So you will write 3 resonating structures for NO3 minus, in which double bond, double bond, double bond. Okay? Now other concept in this is bond order for resonance. In NCERT, this is not given for bond order, they have given only for molecular orbital theory. It is given only for molecular orbital theory, but it is useful sometimes to explain the bond length comparison in polyatomic molecules. Because in NCERT, MOT is given for a diatomic, that too homodiatomic. Okay? But in resonance, we are using the polyatomic molecule, so sometimes bond length comparisons are easily done by using bond order from resonance. So how to find bond order for in resonating structures? So bond order will be what? Bond order will be equal to, bond order means what? Number of bond between the 2 atoms in the structure. So here it will be what? It will be, there are multiple methods, like write down the all structures, and then count the number of bonds between any 2 atoms. Like here I am marking, suppose this is 1, it is 2. Then other atom also here, this is 1, this is 2, it is 1, it is 2. Okay? Then in all the resonating structures, count the bonds among them. It will be 2 here plus 1 plus 1. Kitna? 4. Okay? 4. Divide by the resonating structures 3. Divide by the resonating structures 3. The 4 by 3 will be the bond order. Other method is that you write the structure only 1. You know the concept that resonating structures we can write. Count the total number of sigma and pi bonds in the structure where resonance is taking place. Here resonance taking place, here also, there also. So here sigma and pi bonds in the structure, divide by number of sigma bonds. That is also giving you same answer. So it's up to you which method you can use. Either you write all the structures, find out the number of bond between any two atoms in all the structures, divide by resonating structure. It will give you answer. Other easy method is write down the structure where resonance is taking place, count total bonds, sigma plus pi, and divide by sigma bond. That will be much easier for students, I think, because you don't have to write every time the all possible structures. Example, in O3, in O3 molecule, already structure you have written. This is the structure. I can write both structures. I can write both structures, or I know that here resonance taking place among them. How many bonds there? 3. How many sigma bonds? 2. 1.5 is the bond order. Getting it? So this is somewhat easier, but if you remember any other method which is correct also, you will get the same answer. You will get the same answer. आई बात समझ में? Same will try for which one? NO2 minus. Same will try for CO3 2 minus. Same will try for benzene. NO2 minus structure already written. So I'll write again. Resonance taking place where? Among them. How many total bond? Sigma plus pi 3 divided by 2, 1.5. Carbonate ion. You can write all the structures or you can write this structure itself. Resonance taking place everywhere. How many total bonds? 4. Divided by how many sigma bonds? 3. कितना आ गया? 1.33. Getting it? So it's up to you. Again, I am saying if you have understood any other method, you can apply that one. There is no point that I am saying do this which I am saying. They are all similar. No problem with anyone. Answer remains same. Try this example. Benzene. In benzene, what's the bond order? Resonance taking place where? Among carbon-carbon, not hydrogen. So I will not count their bond. I will count total 6 sigma bond and 3 pi bond. कितना है? 9. How many sigma bonds? 6. कितना आ गया? 3 by 2, that is 1.5. So bond order of carbon-carbon bond in benzene ring, it is not equal to 2. It is less than 2. How much? 1.5. Getting it? PO4 3 minus structure. Phosphorus. How many oxygens getting minus 1 charge? 3. And 1 will be double bond O. So you can practice this structure also separately in terms of VSCPR model AB4 type structure. One way is write all the structures. That is time consuming. I'll write all are undergoing resonance. So कितने सिग्मा और पाई? 4 और 1 5 बटे 4 1.25. आई बात समझ में? Getting it? So that way you can compare bond lengths whenever you are getting the any question about polyatomic structure where resonance is possible. You can compare bond length of CO, CO2 and CO3 2 minus. You can compare bond length of O2 and O3. आई बात समझ में? Till this point, any question you want to ask? This example yesterday we have done. Bond order, same concept here. Bond order will be 3 exactly. Bond order 2, bond order अभी बताएं कितना 4/3 1.33. Bond order inversely proportional to bond length. Same way, O2 bond order is exactly 2. No resonance. O3 1.5. Oxygen bond length. Written. So this is the concept of resonance. Any other example is there for the carbonate ion? Already I have given. Bond order set, carbonate ion, CO2 important example covered. Very good. So that is the part of the resonance. Try examples as per NCERT. ठीक है ना? Try the example as per NCERT. It is sufficient for resonance. Do not go beyond that. Read the theoretical parts. Statement type questions can be framed from NCERT. Okay. Now, any questions you want to ask? Any questions from your side? Test syllabus. Remember, keep on checking your WhatsApp group, wherever you are added now. Check the WhatsApp group. Syllabus might be possible to be revised. Yesterday, I came to know that today it will be decided again. In some other place, some requirement is there. So keep on checking the revised syllabus. It might be possible that some less syllabus will be there, like resonance, but you will complete it today. You will complete it today, okay? Not added, Alexander. ठीक है भाई. Any other question? So I think you can go for breakfast, or you already had your breakfast maybe by 7. So we'll meet in the next lecture. Done? That time you can ask questions, solve it. Okay? Take care. Bye-bye.